Hello my dear and lovely students. I first welcomes you on behalf of the EduSat sponsors Government of Odisha's e-learning class, and up to that you know that when the atomic physics chapter being your the completed, the anxiety must comes in your the mind when the nuclear physics to be your the start. And today that type of the anxiety from your the face, it will going to be your the out when I will go through your the nuclear physics. And the nuclear physics is that branch of the physics which deals with the study or the character and the nature of your the nucleus. Then the question comes, so what is your the nucleus, what are its the constituent parts? About that we are going to discuss on your the very first class of the nuclear physics, which I given it as the name of your the nuclei of 1. So, in the nuclei 1 we are going to discuss about your the nuclear terminology and its the notations, nuclei classifications, intrinsic properties, atomic mass unit and your the energy level with its the nuclear stability. And you know very well that the science is not developed in a overnight, and any branch of the science what you know either in the physics or the chemistry, mathematics, botany, zoology or whatever it may be, it being your the going on the developed from day to day. So, if first some idea being developed not only by a single person, different persons all over the world they thought about that one, they given some concepts. By taking that concepts, a group of the scientists they to be decide actually what they thought, is it correct or not. After that the experiments are going on. By basing on the experiments, the different developments are enhancing from day to day. And in your the nuclear physics, in your the atomic physics or in your thermodynamics or in the electronics or in your the magnetism or in the current electricity, the development in every time it is going on your the increasing. So, regarding your the nuclear physics, let us first go to know what is the history behind your the nuclear physics. So, when we are going to discuss about the history, it must have its the day to day development. So, history of nuclear physics. History of nuclear physics. So, a history means the first idea So, likewise in the different years the different developments are going on. So, in the 1896 that is called here the birth year of nuclear physics. When this idea of the birth year being developed by the Henry Becquerel, you know the Becquerel's name, and the Henry Becquerel developed the discovered radioactivity. About the radioactivity, you know in your the chemistry, we also discuss in your the nuclear physics detailing about that one, radioactivity of a uranium atom in 1896. In 1897, the Thomson's model as developed in your the atomic physics, not your the Andhra Pradesh, that is the AP, in the atomic physics, the Thomson's model, that is your the plum pudding model. And in 1911, by your the Rutherford, that your the alpha scattering. In 1913, by your the Bohr's model. In 1932, by your the Chadwick discovered neutron, and in 1947 group of Mayer, Jensen, Haxel, group of physicists Mayer, Jensen, Haxel, they developed the different properties of your the nucleus. So, if you will go for your the Becquerels in your the radioactivity means the spontaneous disintegration. Disintegration means integration means taken together, disintegration means it is going out. Means from a particular place something being your the radiated out, some rays to be your the radiated out. And they thought if it from a particular position it being your the radiated out, then what will be that position, and that position they developed or called as your the nucleus. Nucleus. So, inside the nucleus different particles are there which are developed by your the group of the physicists, they are the Mayer, Jensen and your the Haxel. So, if we will go for your the discovery of the different parts of your the atom. So, atom means it is your the central part and the electrons are revolving around that one. On your the screen you will find that the electrons are revolving around your the nucleus, and the nucleus consists of your the positive charge particles. And next we will go for your the atoms different structures like your the Thomson's model and your the Rutherford's model. As I said that in the Thomson's model, that is the plum pudding model, and that plum pudding model it shows that the electrons they are the outer side and your the positive charge particles they are the remain at its the center, and that central part is later known as your the nucleus, and the nucleus is your the positively charged, we will come to know later. Next your the Rutherford's model. In the Rutherford's alpha scattering model it showed that when the 10,000s of the alpha particles are coming and towards your the atom, a very few means only 1 to 2 alpha particles just their returns, and that returns of the alpha particles means the scattering of that alpha particles shows that the central part is your the core element, and that core element later it is known as your the nucleus. After the discovery of the nucleus, Chadwick has given the idea of your the neutron, and from that idea for the neutron the new era of nuclear physics being your the developed. After that the different properties of that nuclear particles given by your the Mayer, Jensen and your the Haxel. This is a brief history of your the nuclear physics. Next we will go to find what will it is the terminologies which are associated with it. So, in the terminology means the different terms which we know about your the nuclear physics. So, that terminology and notation. So, before the terminology and your the notation, the different properties which are given, that nucleus is divided into 2 models. It being divided into the 2 models. The one model is your the known SIM, the second one is your the IPM. So, students, when I said about the word, the model's name is your the SIM, you must have gone through your that world that, so we know very well what is the SIM. About the name of the SIM, each and every persons of this world they are acquainted with that one. But if you will go to ask them what is the meaning of the SIM which they are saying in the sense of your the telephones, means your the phones which are available in a house, you will find that 5 to 6 phones at least you have in your the homes, and each and every phone have your the SIM. So, what is the meaning of that SIM? That SIM meaning if you will ask for your the 100 persons, I think that at least 99% or the 99% they will not answer what is the meaning of the SIM, but they will say that we know very well about the SIM, and that SIM is in the phone, that is the subscriber identification module. So, subscriber identification module means regarding to that SIM, if we will do any type of the in proper way, so we can be the handled. So, that is your the subscriber's name in your the phone, but here the subscriber SIM not your the subscriber, that is your the strong interaction model. That is your the strong interaction model. So, the strong interaction model means what it gives about the strong interaction model, that also known as your the strong coupling model. Strong coupling model. So, how it happens? Let us go for your the atomic structure. Suppose this is your atom. The central part we are saying that is your the nucleus. So, around the nucleus the electrons are revolving. This is your the electron. And the central part is your the nucleus. This nucleus is the very smaller part of that one. Very smaller part. So, how it is a very smaller part? Suppose we are inside your the some room. You are sitting in your the TV room. Suppose that TV room must have its the length and the breadth. If that whole one will be taken as your the atom, then the central part means just the tip portion of your the fork, the tip portion of your the pen, or you can say if you take the needle, the tip portion of the needle means a very small part will be its your the nucleus, that was known later. So, if that is your the nucleus, inside the nucleus other particles are present, that other particles are the proton and your the neutrons. The protons are your the positive in charge. So many protons may be present there, only the without a single proton it has its structure as your the hydrogen. And if you go for your the higher elements, you will have the number of the protons, and that protons they are to be or the bound, means they to be or the coupled. Coupled means they are joined together. So, by that joining they will have a force. Due to that force they are in its the motion, means the nucleus of your the nucleus which is coupled by means of your the strong force, if they are in the motion, then that is known as the strong interaction model. And another one is your the second one is your the IPM. So, if we will go for your the IPM, means you can remember it, the IPM means your the myself, I is the PM, I is the PM, I means your the myself, PM means your the Prime Minister. In this way you can remember IPM. Likewise I said for the SIM, this is your the IPM. So, IPM means this is your the intermediate portable model. So, in the intermediate portable model, the example is your the cell model. So, what happens here? Here also the nucleons are present. So, a nucleons in comparison with here the other nucleons which are possesses its the potential energy, due to that potential energy this nucleus is in the motion. Here due to your the strong interaction force they are in the motion, therefore that is the strong interaction model, and this is the intermediate portable model. And this strong intermediate model, that is your the liquid drop model. Liquid drop model. So, if you just put your the waters to the downward position, you will find that after some time the droplets of the water will comes out, and that droplets of the water which are comes out, that is your the strong coupling models example. So, these are the two models which are given by the different scientists whose names, as I said, that the Mayer, Hexel and the Jensen etc. they show this type of the models. Next we will go to find what is the terminology and the notation. The terminology means the terms which are associated with it, and the notation means the symbols which we are using. Like here the electron, for here the electron we are using the symbol of here the E, and for here the proton we are using the symbol of here the P. So, likewise for your the other particles we will discuss. So, if you will go for the electron and your the proton, they are the particles of the nucleus, but this electron it is your the most fundamental particles, means it will never to be the divided, but these protons and the neutrons which are present they can be further divided. So, we will discuss that what are the further parts of the nucleus. So, if we go for your the nuclear physics, we came to know about its the history, and that history will have its the different years, and then we are going to discuss about the notations with its the vividly. So, as we came to know that there are the two different types of the models, one is your the SIM, another one is your the IPM, and then we are going to find what are the terms associated with your the nucleus. So, let us now go for your the one by one. The very first one is your the nucleus. Nucleus. So, it is the central mass of an atom having all positive charges. The central mass of the atom having here the all positive charges. You see, I am saying about the word of here the atom, and in your the atom, this is its the central part which is your the nucleus, and this is your the electron. So, if the atom to be the consider, the mass of the atom is nothing but the mass of the nucleus only, the mass of the nucleus only, and that mass of the nucleus will be the total mass of its the constituent particles, they are known as your the nucleons. So, if we will go for your the nucleus, if the electrons are there, but the electrons parts are very negligible, and if we will go for the nucleus radius and your the atomic radius. What can you say, my dear students, about them, the nuclear radius and your the atomic nucleus? This is your the nucleus, though it is present inside that one, you can say that its radius must be your the smaller than that of your the atom's radius, because the this dotted one, that is your the atom, this is your the atom, but this is your the nucleus. The radius of the atom is 10 to the power of minus 10 meter, but the radius of the nucleus is 10 to the power of minus 14 to 10 to the power of minus 15 meter. And you know that 10 to the power of minus 15 meter, that is known as the femto. That is known as the femto. So, this 10 to the power minus 15 meter is also written as the 1 FM, femtometer. 10 to the power minus 15 meter is equals to the femtometer. So, if this is 10 to the power minus 10, that is the 10 to the power minus 14. This 10 to the power minus 14, if it to be elaborate for your the mind freshness, 10 to the power minus 14 will be the 10 to the power minus 10 into 10 to the power minus 4. So, this 10 to the power minus 4 you can write that is equals to that by your the 10 to the power 4. This 10 to the power of minus 10 meter, this is nothing but your the radius of your the atom. You see, atomic radius is 10 to the power of minus 10. So, if this is the atomic radius, that divided by your the 10 times of the 1000. So, 10,000 or 10 times of the thousands part of your the atom is your the radius of your the nucleus. Means if this one will be your the nucleus, its radius is very very small in comparison to that of your the atom. Therefore I said that if your room is your the atom, then the tip portion of your the needle will be its the nucleus, and if that nucleus contains the number of the particles, then what will be its the density, what will be its the volume, you can imagine, and we will discuss in this one of the terminology. So the first one is your the nucleus, which is written with your the Zd. If Zd to be the symbolized, which is the notation, then you can say that is your the nucleus, where E is your the charge of the electron, Z is your the number of the protons, and the protons charge and the electrons charge in magnitude they to be the same, and it will be written as your the nucleus. Next comes your the atomic number. Next comes here the atomic number. Another term is your the mass number. Atomic number or the mass number. The atomic number, that is your the number of the electrons which is present, that is known as your the atomic number, and one is its the mass number. So both these two are your the numbers. So when it is the number means they are only your the integers. So this atomic number will be your the Z, and this mass number will be written as your the A. That is your the mass number. Another one is your the atomic mass. Atomic mass. Atomic mass means the mass of the atom. That mass of the atom, as I said, that it is nothing but the mass of your the nucleus. Next, another term is your the nucleons. One is your the nucleons. And before going to nucleons, there are the two terms you have to know. One is the proton, one is your the neutron. The proton is symbolized as your the P, and the neutron is symbolized as your the N. The sum of the proton and the neutron, that will give you the nucleons. These nucleons will be your the sum of proton and neutron. So if the proton, you see the proton is symbolized by your the P, this is your the P, and the neutron is symbolized by your the N, means these nucleons, which is your generally represented as the mass number, that A will be your the P plus of your the N. A will be your the P plus of your the N, that is its your the mass number. But I said there is another one is your the atomic mass. This atomic mass is generally represented by your the symbol of your the M. So what is the difference between this atomic mass and your the mass number? This atomic mass means the mass of your the atom. The mass of the atom means, you see, we said this total one is your the atom. Of this, the number of electrons are there on its the outermost orbit. At the center, that is your the nucleus. If at the center is the nucleus, means the total mass of the atom, as we taken that is the mass of the nucleus only. So sir, then the question comes, sir, what about for the electrons mass? If the electrons are there with the atom, why we are taking the atomic mass number, the atomic number and the atomic mass, it is only due to your the nucleus only, because these atoms consists of your the nucleus plus electrons, and this nucleus has your the proton and the neutron. Proton plus a neutron is your the nucleus, with your the electron, that will be your the atom. And why we are taking only the mass of the nucleus as the mass of the atom, why not your the electron's mass? And you know very well that the mass of electron is 9.1 into 10 to the power of minus 31 kg. the mass of electron is 9.1 into 10 to the power of minus 31 kg, and but the mass of the proton and the nucleus, if you will consider, then they are your the 1.6723 into 10 to the power of minus 27 of your the gram. That of the 27 of your the kg, and this is 10 to the power of minus 27, that is the 10 to the power of minus 31. Again it comes of the 1 by your the 10,000 times. Therefore, 1 by 1837 times of your the mass is less than that of the nucleus of your the electron. And for your the nucleus, if the number of protons and electrons are there, they have your the this type of your the mass, and the electron has the this type of the mass, and this mass you see, this is the very negligible in comparison to your the proton and the neutron. Therefore, though the electrons are there, no doubt, but that electron's mass is very negligible. Hence, the mass of the nucleus is generally taken as your the mass of your the atom. So, this is your the terminologies which we are using about your the nuclear physics. So, in that terminologies, most applicable symbols we will use further, that is your the P and your the N, proton and your the neutron, and further that proton and the neutron are to be the subdivided. Therefore, I said that this proton and the neutrons, they are not the fundamental one, they are to be the further divided. As per our the terminology, we came to know that inside your the nucleus the proton and the neutrons are present, and outside your the nucleus the electrons are revolving. The proton, neutron and electron, they have their the charges, and if you take in your the tabular form, as you look in your the screen, that the particles we have written as your the proton, neutron and your the electron, with the symbols as your the P, N and your the E, with their the mass and the energy with their the charges, and this is about its the nucleus. So, if we go for your the representation of your the any atom, that representation is generally is taking place for your the symbol X. So, X, as we are saying that we do not know anything, then we are saying that let it be your the X. So, this is your the X, means it will start from its the hydrogen up to your the number of the elements which are present in your the periodic table. So, there it is represented by your the symbol of your the Z, which is its the proton numbers, number of proton, and there is a symbol of your the A, and this A is its the mass number. You see, this is the mass number. I said this is the mass number, means purely it is a number, and this is your the proton numbers, and this X is your the element. And when this is its the X is the element, this A is the mass number, it is nothing but the number of proton plus of your the number of the neutron. But here it is designated with your the proton, but how you will represent the number of the neutrons? Then this X in some symbols will be written, X is the element, Z is its the proton number, A is its the mass number, and for your the neutron you can write at the N on your the right side with its the subscript, and at the superscript there is a symbol A, that is its the mass number, and also there is a subscript to the left, that is its the proton, and in some way this also written as your the X of your the A, Z, comma of your the N. This is also one type of the symbolization, and in your the different ways of the symbolization is the name of element followed with its mass number, with its mass number. Suppose you will say the element is your the uranium with its the mass number of your the 235 or 238 likewise. The second way which is the chemical name followed by the mass number. Followed with the mass number. So, one is the name of the element followed with the mass number if the element is the uranium of the 235, or if you will say the oxygen with its the mass number of here the 16 or the 15 or the 17 or the 18. Similarly, the chemical name followed with here the number. So, for this one, if it is the uranium, the chemical name is your the chemical symbol, that is your the U with its the 235 or 238. Suppose for your the oxygen, you can say your the O with its the 16 or the 17 or your the 18. So, after knowing this one, let us go for your the example. Suppose I will say N1123. So, this not A, that is the Na, Na11 with the 23. So, you see 11 at the left side, on the left side that is your the Z. So, this one can be written as your the X, Z, A. Clear? This is your the Z. What is the Z? Z is the proton. So, the proton number is your the 11. So, here proton is your the 11. Then comes here the A, you see A is the 23. What is the A? A is the mass number. That mass number is your the mass number is your the proton plus of the neutron. So, proton is the 11, means that is the 11 plus neutron is equals to your the 23. So, therefore, the neutron will be your the 23 minus 11, that is your the 12. Therefore, the neutron N is equals to your the A minus of your the Z. You see, A is equals to P plus of your the N. So, P is equals to your the, what is P? P is your the proton and N is your the neutron, and the N is your the neutron and P is the proton. So, the proton number is your the Z and this is your the N. So, N is equals to your the A minus Z. So, N is equals to your the A minus Z. This is one of the example. Suppose I will give you another example for your the chlorine. Chlorine with your the 17 of your the 35 say. So, this 17 of 35 means you will now make your the preparation for the proton and your the neutron. Can you say, students, what will be the proton number here? The proton number will be your the 17. The neutron number will be your the proton plus neutron will be your the 35. Therefore, the neutron number will be your the 18. So, these are the symbolization of your the nucleus, how you have to represent that representation, either this one or the representation is your the this one. So, next we will go, what we will see the classification of your the nuclei. Classification means you have to classify them, means the different types. Next one is your the classification of nuclei. The first type of a classification is your the isotopes. So, these isotopes, it is nothing but it is the sum of the two words. Iso plus top is your the isotope. This isotope means your the same place. Means from the meaning we are saying that it is of the same place. Same place means the place to be or the remain or the same. So, when it will taken in its the periodic table with its the different positions, that element's place will always remain same. Then what is its the definition? Atoms having same element will be the same. that element is represented with its the proton numbers. The proton numbers will always to be the remain same. Atoms have the same element with different mass numbers. With different mass number. You see, having the same element means the proton number. So, proton which we are written as your the Z, that to be are the same or having the same element. So, this Z to be are the same, but with it the different mass numbers. So, the mass number that we have written as your the A to be your the different. So, A is what? This is the sum of your the P and your the N, not prana natha, that is the proton and your the neutron. So, this is your the P plus N, that to be of your the different. This is your the different. So, if P and the N to be the different means what you will say? The P will be the different and the N will be the different. So, let us now go for it see the example. So, if I will say 1H1, then 1H2, then 1H3. Let us now come for this example. 1H1, 1H2, 1H3. So, this is the symbol. So, symbol how it to be written? XZA. You see, if this is your the X means your the element, the symbol of your the Z with your the A, you see Z, 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 Z is the same here. So, when the Z to be are the same here, what happens for it? See the mass number? The mass number to be are the different. You see here the mass number is 1, here the mass number is 2, here the mass number is the 3. So, this 1H1 is known as your the protium. This 1H2 is your the deuterium, and this one is your the tritium. So, this is the one of the example of your the isotopes. If you will go for your the another type of the example, suppose you will say for your the chlorine with your the 1735, chlorine 1737. Chlorine, a 1735 and the 17 that one, that is the chlorine. As I said, uranium 92 235, uranium 92 236, uranium 92 238. For your the oxygen O8 16, O8 17, O8 18. These are all your the having your the same number of the protons, but with it is the different mass numbers. So, one of the question, and you will find very frequently in your the periodic table, that the chlorine has its the isotopes with the mass number of your the 35.5. Chlorine isotope is your the 35.5. So, can you say that this 35.5 is its the mass number, though it is another subscript of on its the left or to the right? If this is its the mass number is your the A, which is the sum of the proton and your the neutrons. So, these proton and neutrons are only the numbers, but the sum of the number is give you the fraction. Sir, is it possible? Means either the proton is of the some fraction or the neutron of the some fraction. Is it never to be the possible? But if it is never to be the possible of the proton and the neutrons number to be the fraction, but how it's the fractional number it comes? Similarly, for your the calcium, for 20 of your the 40, this 40 also, that is your the 39.5. So, how it is the fraction? And to find that fractional, let us now we will discuss for its the detail. So, for its the average mass number for its the average mass number. Sir, why the question average comes? Because it is the isotopes, means it has its the different elements, different positions of your the proton and the neutrons. So when the different protons of the neutrons you have taken, suppose the chlorine atom, chlorine element is present, and you just take out some chlorine, and you will observe that chlorine has its the mass number of your the 50 of the 35 or your the 37. But that 35 and the 37 numbers on that of the atom, they are not to be the same. It may be of the proton to be the more or the neutrons to be the more. Therefore, in order to find its the average one, you have to find that average number will be the sum of your the this one, A1 N1, A2 N2 plus A3 N3 likewise. That's average you have to take it, where A1 is your the mass of first isotope, A2 mass of second isotope, N1, capital N1 we have taken, N1 is the percentage of first isotope, N2 is the percentage of second isotope. Clearly go through this one. A1 is the mass of the first isotope. Suppose we are going for the chlorine of your the 1735, chlorine 1737, 35, 37. So for this one we are going to find. So if it's you will go to find it's the average one. So average will be A1 N1. Here there is no question of the A3 N3, because the third one we are not taking, we are only taking for the chlorine of the 1735 or the 1737. So A1 is what? A1 is the mass of your the first isotope. So for the first isotope, that is equals to your the 35 into, next one is the N1. N1 is the percentage of the first isotopes. Means if the chlorine atoms are there, just you take out your the chlorine, and the number of the chlorines which you will find for its the mass number of 35. For the mass number of the 35, and that observe that is your the 75% you will get. Suppose the chlorine 35, chlorine 37s are there. If you will take out your the, then chances of the finding of the chlorine to be your the maximum, and 35 will be the maximum, that is your the 75% of the chlorines are there. And for the next one, that will be your the second one means A2N2. A2 is your the mass of the second isotope. The second isotope mass is your the 37 into its percentage. If one is gone to your the 75, what happens for the next one? The next one must be of your the 25%. Means if you will take out your the nucleons of that one, you will find that the 25% of the having mass number of the 37. So that is equals to your the 25%. That is the 75%, this is the 25%, means that is the 35 with the 75 means 75 by 100, and this is equals to with the 37 with the 25 means 25 by the 100, and this is equals to 35 into 1 by 4 plus 3 by 4, that is equals to of the 1 by 4. So now the LCM is your the 4. 35 into 3, 3 5 15 of your the 105 plus 4 with your the 37, that is equals to 142 by your the 4. 142 by 4 is equals to your the 35.5. So 4 with the 3 is the 12, 2 with the 22, 4 with the 5 is the 20, then here the decimal, then 2 with the 0 is the 20, so 4 with the 5. So 35.5. Therefore, the chlorine isotopes is also written either with the 1735.5 or with your the 17 of your the 35.5, either for your the 35 or for your the 37, that is the average one. So this is about your the isotopes. So, about the classification we discussed about the one that is your the isotope. So, next one we will classify it as your the isofather. Isofather. So, iso bar, bar means not your the bar, that is your the iso bar, the name is your the iso bar. So, what will be say the iso bar? Same, the here it is your the same Z different A, and for your the isobars, atoms having same mass number, atoms having the same mass number with different P and here the N. It having here the same mass number means A is to be here the same, P and N to be different. So, when the P and the N means proton and the neutrons are to be different, then its chemical properties to be different. Chemical properties to be the different. So, what will be the example? Suppose SNSB with your the 50-131, this is your the 51 with your the 131. So, this is your the SNSB or your the argon with your the calcium. So, if you do the SN with the SP, SN is the 50. So, 50 is what? This is your the Z. And this is your the 51, this is what? This is your the Z. So, what happens for your the Z? You see, we have written that P and the N to be the different. Z means the proton. So, the proton numbers to be the different. And here the 131, 131, the upper 131, that is its the mass number. This upper 131, that is also the mass number, and this 131, 131 is your the same. So, the mass numbers are to be the same, but it is the proton numbers to be the different. But we have written not only the proton, the neutron also to be the different. So, what will the number of the neutrons here? From 131 you have to subtract the 50, so that will be the 81. And what will happen for this one? That will be the 80. 110, 13 with 5 is the 80. So, here the 80 is your the neutron number, here your the 81 is your the neutron number. You see, we have written that proton and neutron to be the different. So, proton and the neutrons are your the different. Here the proton is 50, here it is the 51, here the neutron is 81, here the neutron is your the 80. So, this type of the classification of the elements is known as your the isobars. Next we will go for your the third one, that is your the isotones. For your the isotones, you see iso means what? We have written in your the isotope. Iso means your the same. So, one thing to be your the remain same. You see here the same is your the Z. Here the same of your the atomic number having your the same mass number means your the A to be your the same, P and the N are your the different. This is for your the isobar. And for your the isotones, what will happen? The neutrons to be your the different. The neutrons to be your the different. But what will happen here? The protons and its the atomic numbers A and P to be same, and a neutron to be different. Neutron to be the different. Suppose I will write 1s3 and He24. You see what is your the 1 and what is your the 2? 1 and 2 is your the Z number. Means your the Z numbers to be your N. N means your the number of your the neutrons to be your the different. You see 1H1, 1H with your the different neutrons to be your the same. Because this is the tone. Tone means your the neutron, ton. So this is the N to be your the same and the A and the P to be your the different. You see this is your the P means your the proton, this is your the 2, that is the proton, 1 and your the 2. So 1 and 2 means the protons are your the different. This is your the 3 is what? Your the A. This is 4 is what? That is your the A. Means your the mass numbers to be your the different. You see A to be your the different and your the P to be your the different. But what to be your the same? The same will be your the neutron. So what will the number of neutrons here? 3 minus 1, that is the 2. This is the 4 minus 2, that is the 2. Therefore the proton is your the neutron to be your the same. When the neutron to be your the same, then that is your the isotons. Similarly, these are the examples of the oxygen with your the nitrogen you can also take. So this is the third type of your the. Thank you very much.